For our last nuclear decay, we're going to talk about gamma decay, gamma radiation. But to do that, first of all, we have to talk about the electromagnetic spectrum because gamma is part of the electromagnetic spectrum. So your electromagnetic spectrum has these different wavelengths from radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma. The distance between the two crests or the two troughs is called wavelength. Now, in a second's time, how many of these wavelengths you have is what's called frequency. So if we look over here on this end, you have longer wavelengths, but less frequency. Over in the gamma, we have shorter wavelengths. There's a shorter distance between the crest, but there's more frequency, okay? With that, as we get over here, we get what's called ionizing radiation. So you had that TED Ed where they talked about the difference between the lower energy and the higher energy. So hopefully you've watched that. But this ionizing radiation is what we're going to talk about for our last decay, which is called gamma decay. Because gamma decay is an electromagnetic radiation, it is not a particle. So we show it like so. That's a horrible Y. Let's try that again. It's supposed to be a weird little Greek Y, but that was really bad. So we're going to try it again. So no mass, no charge. That's probably as good as you're going to get. So during beta, we showed carbon-14 decaying down by beta decay. And you got yourself nitrogen-14. But what I didn't show you was that there's also gamma decay that comes along for the ride. So gamma is not going to change the mass or the atomic number, but it is the ionizing radiation that is released along with this decay. Now, some things will just go ahead and gamma decay on their own, and they don't go through these beta decays or alpha decays, but sometimes gamma is along for the ride with another type of decay. What you want to know is that the mass will not change and the atomic number will not change. Gamma is the most damaging, it is the most penetrating. And this is when we start talking about the medicine, like how we use this to ruin the DNA of those cells, which is what we want to do for cancer cells. But unfortunately, the gamma decay can also mess up the good DNA, which can then cause cancer as well too. What's needed to block this is going to be lead or very thick concrete. That is your last of your radioactive decays.